This lesson focuses on how we take the product of numbers and raise that product to a particular power. We're going to take a look at some numeric examples so we can look for patterns in our work. We'll begin with 3 times 4 raised to the second power. That means if we're talking about factors only, we're talking about taking 3 times 4 and multiplying it by 3 times 4, which is the same, of course, as 12 times 12, and that gives us a product of 144. That same type of pattern would happen with 3 times 3 raised to the third, 2 times 3 raised to the third power. We're going to take 2 times 3 times itself, which would be the same as 6 cubed, or 216. And then we'll write out one more example to investigate. And let's take some bigger numbers. Let's use 8 times 6 squared, which would be 8 times 6 times 8 times 6. And that's 48 times 48. And if you check my work on a calculator, you'll see that that product is 2,304. Well, I notice in my work that I'm using the same factors repeatedly. So for example, with the 3 times 4 squared, I'm using 3 as a factor 2 times and 4 as a factor 2 times. So I'm curious to see if this statement, 3 squared times 4 squared, gives me the same product as what we see over here. So if I look at that from a different way, I know that 3 squared is 3 times 3, and 4 squared is 4 times 4, which is 9 times 16, and that product is also 144. So it looks like we can rearrange factors and write equivalent statements for this power. 2 to the third times 3 to the third would be the same as 2 as a factor 3 times 3 as a factor 3 times, which is the same set of factors I used on the left. And that also gives me a product of 216. And then finally, 8 squared times 6 squared allows me to use 8 as a factor twice and 6 as a factor twice. And I get 64 times 36. And there again, I get the same product that I got on the left. So in our observations, we can summarize that the product taken to a power seems to be the same as each of those factors taken to that power. So 3 times 4 squared appears to be the same as 3 squared times 4 squared. And that same holds true for the other two examples that we used. In general terms, we can write an algebraic example using variables like we have on previous properties. But this time we need 2 bases, so we'll let a and b be our bases, and we will use m as an exponent, as our power. So to find the power of a power, we're simply going to multiply the exponent on each base by the new exponent. And that's a lot to think about. So let's take a look at our algebraic example. If we're multiplying a times b, and we want to take that product to the exponent of m, that means we are going to need to take a to the m power and b to the m power also. So down in our practice, let's take a look at what would happen if we had x multiplied by y, 2 different values that we don't know about it, so we can use variables, and we're going to square that product. So another way a mathematician could write that would be to say, well, I'll take x to the second power and multiply that by y to the second power. Our second practice, we actually have what's called a coefficient, or a number in front of our variable. That doesn't change what we do. We are still going to take this exponent, this power of 5, and distribute it to the 2 and to the x. So that means we're going to take 2 to the 5th power, and then we're going to do x. This time, because x has a power already, we need to multiply those two. So we're going to do 2 times 5, or x to the 10th power. Our next one's a little more complex, but we're getting pretty good at this. So we're going to take that square outside the parentheses, and we're going to distribute it to the coefficient of 4, the variable of y, and the variable of x. So we need to do this 3 times since we have 3 different bases. So this is going to give to the 2nd power times y to the 3 times 2, or y to the 6th, and x to the 2nd power. Okay. And in our last example, we'll have 2 to the 4th power. I'm going to write down here so I have more room. 2 to the 4th power, a to the 2 times 4, or the 8th power, and b to the 4 times 4, or the 16th power. So notice how we had to multiply the power on each base by the power outside the parentheses. So this would be a good time to review what we've done here and then go on to the independent practice and give it a try and see how you do.